All right, now we're going to be talking about Jovian atmospheres. And the point here is that this is the region that is above most of the planet. Okay, we saw the structure in the last segment. And this time we're talking about atmospheres. And it's kind of really odd to talk about an atmosphere on a planet that is basically made out of gas and has no surface at all. So with the terrestrials, we were always talking about planets that had surfaces. Mercury, Venus, the Earth, and Mars all have, they all have an atmosphere to a certain level, but they also have a surface. Now, the only way to think about Jupiter and Saturn especially, and we normally talk about them as gas giants, they really ought to be considered liquid giants, because remember all that metallic hydrogen and liquid hydrogen that was on there? That is not a surface. It's basically, a liquid. It's like a big, huge ocean. And then you have this atmosphere sitting up on top of it. Now, as you know, especially if you live in Los Angeles, if you have clouds of different types, then they reflect light in different ways. In the morning and the evening, we have a lot of red light that is still going through the atmosphere, and the clouds turn up to be various colors of pink and red. You can have a green flash very occasionally, but basically, by and large, the clouds are, basically sort of monotone. Now, if you live in an area with lots of smog, then you're going to get a lot of brown. And if you've ever been in the area when there's been forest fires and such, we get lots of smoke, and indeed the air gets very, very dark and heavy and filled with, obnoxious dark brown sorts of stuff. And that's what we're getting out of here with Saturn and Jupiter. And so just like the Earth has various portions of the atmosphere, troposphere, stratosphere, and thermosphere, the same sort of situation applies for Jupiter and Saturn especially. If we look at all the Jovian planets together and compare the temperature as a function of altitude above the cloud tops, going from the troposphere to the stratosphere, then we can see that, we have basically the same sort of situation applying. Temperature goes down for a region and then it increases. And that's different than what we saw with the Earth, because we saw a couple of regions where we had a temperature inversion going on between a lower altitude and a higher altitude. Okay, and I think the reason is basically these guys are so much further away from the sun. So we have various different cloud tops and materials that are reflecting different colors. Okay, now this is the original model of Jupiter's belts and zones, and we'll see a picture of that soon. Basically, to recall, and we'll see this in a little bit, we have a Coriolis effect going on that is giving rise to an east-west flow of belts of clouds. And we'll see that a little bit. Here we go. We have our circulation cells. This is the model we had for the Earth. We have cold air sinking at the poles because it's colder there, and the cold air, because it's heavier, sinks. The warm air rises in the equatorial regimes, and when we have a Coriolis effect, then what ends up happening, as illustrated by this movie, that motion that originally was going north-south will have a component that is going to go east and west. So here you see it's they're just tossing it back and forth, plain as day, and then now we get the Coriolis effect where they just throw it off in one direction and it no longer gets into the person's hands. And then we're going to look from above and we will see that indeed the ball does move in a direct straight line from where it started to move, but it appears to curve relative to the guys on the merry-go-round. So there it went straight ahead, as you can see, but it goes completely out of reach of the person. And then if we're rotating with the frame, we seem to see the ball curving. Okay, so let's take that back to our model. That explains why we have these belts going east and west now. And this is a little bit more about the cloud colors. Jupiter and Saturn are very similar. The difference with Saturn is that it's much further away, so the colors are more subdued. Uranus and Neptune are blue because of all the methane, and the methane absorbs the red light and transmits the blue. Okay, so let's continue on with this thing, and we get these storms that are created. This is the Great Red Spot. Not really red in this case, but this thing is about the same size as the Earth. See here, these things are meant to fit to be about the same size. So you can see this is about 2,000 kilometers, and the Earth's radius is about 6,000. So I think I've got it pretty much. Now, because the rotation rates for these planets are so much more than the Earth being 24 hours, then we're going to have more significant cloud belts occurring, or or those regions that we were talking about here, these circulation cells. Okay, with the Earth we got 3, but we should expect a lot more given the rotation rate that we have with Jupiter and Saturn. So this is what we have with the Earth. We have 3 on the north, 3 on the south, and if we look at Jupiter, we have, look at all these guys, okay, where we have rising and falling convection cells, okay, and we have just, look at all these guys, and up here is the North Pole, and here is the South Pole. Okay, the Great Red Spot, very interesting in its own accord, as I pointed out before. It's about as big as the Earth. It seems to have, lost about 15% of its size for the 10 years between 1996 and 2006. It's been going for 400 years, and as the question implies, will it disappear? And a little red spot was being created during this time period. And here is Red Spot Junior, and that's over here. And then we have the giant red spot. I haven't seen the Great Red Spot yet. And for my telescope, which is an 8-inch scope, it's very difficult to see the even the bands in this colorful way. Okay, the other thing that we can have is magnetospheres, and here is a couple of pictures showing the auroras in Saturn and Jupiter. And remember, auroras go hand in hand with magnetospheres. Okay, so the Earth creates a magnetic field, which creates a field of magnetic field lines, which we call the magnetosphere. So this is the one created by Jupiter. It's so much larger than the other guys, but Saturn, Uranus, and Neptune create them as well. And I believe we do have pictures from NASA of auroras from Uranus and Neptune, although I just couldn't get a hold of them in time. All right, that takes care of it for atmospheres.